Welcome back, guys. I just want to give a shout out for those mindsetters who don't leave their seats for the entire show. And I know that sometimes you guys stay with us from the grade 10 show till the end of the grade 12 show. Some of you are in grade 10, 11, and 12, and you get like revision and you get to see what's been cooking in all the other shows, and you get involved in all the other grades and what they have to say. And some of you are even like, WhatsApp me or Facebook me if you need some help. And guys, that shows just such good compassion and such good humanity as well, because you don't want to pass alone. You want all your mindsetters to pass with you. And just because of the fact that you are a mindsetter, it means that you are already ahead of the rest. So make sure that you keep yourself as a mindsetter and you keep yourself driven, because we will always be here for you. As long as you are here, we are here. So just make sure that you are always here and you do not move from your seats. Heather, are you ready for us?
Absolutely.
Okay.
Guys, at the just before the break, as I was looking at what I had on the board, I had this feeling that I'd made a mistake. And sometimes you shouldn't second guess yourself. Sometimes you should actually go with your first gut feeling, because absolutely everything was fine. Okay. So what we got to our gradient, which we had kind of got from our radius, and we turned it upside down for our tangent. And then we had got to this point, and when I multiplied this up, I had by is equal to minus ax plus bc. I then tried to substitute in the point A and B, and again, that gave me this thing here, which was b squared is equal to minus a squared plus bc. Now, if we had a look at the original, our original wants us to somehow bring in an r squared. So at the moment, this bit here, this by is good. This minus ax is good. But somehow I've got to get rid of this thing, and I've got to bring in an r squared. Okay, so I want you to have a look at the original picture. All right, if you have a look in this triangle, all right, can you see that triangle is a right angle triangle, and using it, I would somehow be able to get an r squared related to my c. All right, let's just look at this thing by Pythagoras. If this is my 90, I would be able to say that OC squared was equal to OA squared and AC squared. Okay? So everybody, I hope you can agree, OC squared is going to equal OA squared and AC squared. Now, taking that down, let's have a look at how we're going to introduce what's going on. So OC squared is equal to OA squared and AC squared. Okay. Now, from the picture, look at it. How long is it from O up to C? Well, definitely that is going to be C squared. How long is it from O to A? Well, that, thank heavens, is going to introduce my R squared. And how long is it from A to C? Now, just focus, because I don't want to keep going backwards and forwards. From A to C is going to be A minus naught squared plus B minus C squared by the distance formula. Okay? So it is going to be A minus naught squared plus B minus C squared, and all of this is by the distance formula. Okay, right, now let's keep on going. So we've got C squared is going to equal R squared and A squared, and when I square this out, I'm going to get B squared minus twice BC and C squared. All right? Now look at what we've got. Can you see that your A squared and your C squareds and your C squareds knock each other off? Now, what do we know about A squared and B squared? Let's go back to our formula. A squared, remember that this thing here is A, this is B, So what do we know about a squared and b squared? I hope that you can see that it's equal to r squared by Pythagoras. So that means that you've now got that 0 is equal to r squared, and a squared plus b squared is r squared minus 2bc. So finally, we've got 2bc is equal to 2r squared. Cancelling out 2's, we now know that a bc is the same as an r squared. So let's go to what they wanted us to prove. We now know that a bc is equal to an r squared. So we have got by is equal to minus ax and r squared. And so finally, we're going to get by plus ax minus r squared is equal to 0. Now you can actually see why I chose that problem, because superficially it looks really difficult. But in fact, if you go through what we've done, it's really not. It's grade 10 with the radius perpendicular to the tangent, the perpendicular lines. And then really what we're doing is we're using grade 10 distance formula and Pythagoras. Okay. Right. I'm hoping that we've now got time for a little bit of trigonometry. And the trigonometry is really going to be based on our compound angles. And remember that your compound angle formula is on your formula sheet. And so there's no excuse for you to actually get this right, okay? Without using a calculator, prove that. Again, you can see I'm emphasizing every single question is how do we go about a prove that? We actually do it, and then hopefully it's going to correlate with the answer at the end. So they want us to actually take the cos of a half x and prove that it comes equal to 1 minus root 3 over 2 root 2. And they want us specifically to work this out if x is 210. So there's absolutely nothing wrong with starting off with x being 210, okay, and subbing it into the original. So if we take our left-hand side, all right, we are going to get the cos of a half of 210, right? Which we know is going to be the cos of 105. Now, this question is completely without a calculator. They do not want you to pick it up and to punch in cos 105. They want you to get it to the right-hand side. All right, so let's just remember that there are two ways to do this. 105 is what we call an obtuse angle. And so the one way that we can actually change 105 is to make it 180 minus 105, which gets me to the cos of 75 degrees. However, because 105 is in the second quadrant, we know that cos is negative there, and so it is negative the cos of 75 degrees. Okay, so that's the one way that we can look at this. The other way that we can look at it is just to leave it exactly as it is. And I'm going to show you the beauty of doing it both ways. Okay, let's say we leave it as it is. That means that we're going to take 105 and we are going to split it into 60, add 45 degrees. Okay? Now remember, your cos formula says that if you have an angle A and an angle B, it is the cos of A, cos of B, minus the sine of A, sine of B. So that means that by substituting into our formula, we are going to get the cos of 60, cos of 45, minus the sine of 60 sine of 45. Okay, so far I'm sure you're with me. Right, now because it's a special angle, we're going to need to get our cos of 60. All right, now some of us work with the right angle triangle method. Some of us cheated on the calculator. But if we have a 60-degree angle, all right, this is going to be 1, this is going to be 2, and this is going to be root 3, and there is my 30-degree. So the cos of 60 is going to be a half. The cos of 45, using my special triangles, is going to be 1, 1, and root 2, and there's my 45. And so the cos of 45 is going to be 1 over root 2. And then the sine of 60 is going to be root 3 over 2 times the sine of 45, which is also 1 over root 2. And so we're going to get 1 times 1 is 1 minus root 3 over 2 root 2. And you can see that what you have got is exactly what they said. Okay? However, let's say that you are so trained into changing every obtuse angle down into an acute angle. And so we took the cos of 105 and we changed it into negative the cos of 75. All right? Now, how is that going to help us? Well, now we've got negative, all right? Now, this is going to be the cos of 35. Rubbish. That's not very helpful. Negative the cos of 45 and 30. Right? Both of them special angles. Keeping my negative outside, that is going to give me the cos of 45, cos of 30, take away the sine of 45, sine of 30. Okay? Which is going to give me negative. The cos of 45 is 1 over root 2. From our picture above, the cos of 30 is root 3 over 2. Then we've got the sine of 45, which is 1 over root 2. And then we've got the sine of 30, which is a half. And you can see here that what we're landing up with is the negative of root 3 minus 1 over 2 root 2. And is that the same as the above? Well, if we introduce our negative, it's going to make it 1 minus root 3 over 2 root 2. And yes, our answer is exactly the same. Okay, before I go on to a kind of a random question, I'm just going to quickly ask if there's any questions that we can go over. Or
Right
can we
now, there aren't any questions on what you're doing on trigonometry, Heather, so you can carry on.
So I can just do something
you can do
separate.
something.
Okay. All right. What I thought I would do is take a nice exponent question that often kind of creeps up in our exams, and they say calculate, and they actually don't even say without a calculator. Because if you were to try and put that into your calculator, even if it was a fancy Casio, 5 to the power of 2007 is most likely going to blow the calculator up. If you've got just a normal calculator, you would have to take 5 times 5 times 5, okay, and by the time your 81st birthday came along, you would still be busy and the calculator batteries would be fraught anyway. So what we need to do is recognize this kind of a question. Okay, we've got 5 to the 2007 plus 5 to the 2010, 5 to the 2008 plus 5 to the 2009. And you can see that I must have got this from a 2007, 8, 9, or 10 paper because they tend to use the years that we're currently in. Okay, let's have a look at what we know about 5 to the 2008. Well, we know that it's actually 5 to the 2007 times 5 to the 1, don't we? And if we took 5 to the 2009, it would be 5 to the 2007 times 5 squared. And if we took 5 to the 2010, it would be 5 to the 2007 times 5 cubed. Now, I chose 5 to the 2007 as my common piece, okay? So what I'm actually going to do is I'm going to let x be this much. And I'm going to simplify it by a reasonable substitution. So this is going to say x plus. Now, what is 5 to the 2010? Well, it is actually 5 cubed, all right, times by x. Then on the denominator, and I'm sure that I've actually kind of spoiled this for you now because you can all see what to do. On the denominator, you're going to have 5 to the 2008, which is just going to be x multiplied by 5. And then 5 to the 2009 is going to be 5 squared times by x. Right, now, can you see my next step? What I've got is a quotient, and I've got a plus sign in between. So please, guys, do not cancel. But what we do have is x plus 125x over 5x plus 25x. Now, of course, at this point, there's two ways again to do it. The easiest way, of course, is just to add them up, 126x, and on the bottom, you've got 30x, and then to simplify. But of course, some of you might have gone a little bit kind of around about the bush. You could have taken x out as a common factor, and you would have had 1 plus 125. And if we'd have taken x out on the bottom, you would have had 5 add 25. And of course, your x's would cancel, and again, you would be left simplifying 126 over 30. And if we just do that, if we divide by 2, we are going to get 63 over 15. And again, if we divide by 3, we are going to get 21 over 5. Now, can you imagine that you've done that gross fraction without a calculator? Okay, anything coming in from that?
Nothing's coming in, Heather, but there was quite a few people that are asking you to go back to that answer that you had on the circle.
Yes.
In the geometry, was it analytical geometry?
Cool.
And they just wanted to see the answer and how you got
So
to
just to
final
revise that.
Yes.
Okay.
Yes.
No problem at all. Okay, so I think that the best thing is that we get it from, I think this point here is
just
perhaps
to recap how you did it.
All right. How much time do we have?
We have about a minute and a bit.
Okay, so I can't be too long-winded. Okay, so guys, I'm hoping that you saw that once I'd substituted my gradient in, then I got a common denominator of b. I had my by is equal to my minus ax plus bc. So that's where I'd got my equation to. Comparing that to what I needed to get to, I had the by and I had the ax, but can you see I need to somehow introduce this negative r squared? So what I'm actually trying to do is get the bc related or make it vanish so that the r squared can come in. Okay, so then I had to have a quick look at my picture and see how could I bring in the r squared. Now the r, all right, I don't know this coordinate down here. So working in this right angle triangle is pointless. But if I'm working in this triangle, okay, then you can see that I can make up a right angle triangle, and I can say that the distance from O to C, which is OC squared, is going to equal OA and squared plus AC squared. And then I do need to just point out that in order to get that distance, I used the distance formula. And then I substituted, and we were done.
Thank you so
we've run
much,
out of
Heather.
time.
We've run out of time. Guys, thank you for joining us for such an awesome show. You guys have been absolutely fantastic. Thank you again to Liberty, and we'll see you for more maths next week. Bye, guys.